Okay, so let's start this, and I'm just trying to figure out a few things here before if I move that, it is recording, good. So let's go back. All right, so first question. So you'll notice if you did day 7, the day 8 is a little bit similar, except maybe the last few questions. So um, let's see. So identify all the parts in the expression, the following expression: 7h plus 4m plus 9. So in this case, I am going to call, let's do the terms first. This is made up of 3 parts: 7h, 4m is 9. How do I know that? Remember I told you the plus sign or the subtraction sign serves as comma, so we know that it's made up of 1, comma, 2, 3. So there are 3 terms or 3 parts here, 3 terms. The 7 is my coefficient. Okay, coefficient is the number that's being multiplied to the variable. And notice that I have 2 coefficients here. The 7 is a coefficient, and 4 is also a coefficient. Okay. And we have one more, and I don't have room there, so I'm going to write over here that 9 is my constant. Okay. And, oh, I have 2 variables. Sorry. Variables. There's a lot here then. Variables, h and m. 2 values. I don't know the value of. Okay. And let's see. How do I get rid of this, or how do I make this a little bigger? Okay, here we go. Good. All right. The maximum occupancy in the gym is 250 students. You gotta understand what that means. So in this case, maximum means that the most the gym can host or have inside is 250 students. Write an equality that describes the situation. So here, let's take what do we call gym? A variable for gym, and we're comparing the gym to the number 250. So what's the relationship between the gym and the number 250? Well, the number of people in the gym has to be less than 250, because anything above that would not work. And could it be 250? Yes, it could. It could also be 250. So it says the maximum, the most gym can have in terms of number of students is 250. And 250 and less. So what are 3 possible solutions? You can write 250 possible number of students in there, 20, 189. Well, those are 3 examples of 3 possible solutions. Describe the community property by giving an example. Well, the community property works in 2 ways. You can use addition, this community property of addition. So 5 plus 3 is the same thing as 3 plus 5. If I switch the add-ins here, will it make a difference or change the sum? No, it won't. And likewise in multiplication, I can say that 3 times 5 is the same thing as 5 times 3. Got it? Let me just go down a little bit more here. And let me actually erase that. Number 4, order of operations. So let's take care of this. So order of operation tells I have to do the exponents first. There are no parentheses, so I'll take care of that first. 125. I'll leave the 24 alone. Divide it by 2 to the third 8 times 15 plus 4. Notice the only thing I did was take care of this guy and this guy, my exponents. Now that they're gone, I can do multiplication and division, and I have a division. So I'm going to do 125 minus, and I'm doing division first because it comes first, not because it's there first. From left to right, it shows up first. 24 divided by 8 is 3 times 15 plus 4. I like to take care of one thing per line, okay, at least until I get very, very comfortable with my order of operations. So next line, 125 minus 3 times 15 is 45 plus 4. And then 125 minus 45 plus 4, I will do subtraction because subtraction comes first. And 125 minus 45, look like it's 80. I'm going to add the 4 at the end. Final answer, 84. So my expression is equal to 84. Translate the sum of 5 and a number in 5. So the sum implies addition. What am I adding? A number that I don't know, I'll call it n, and 5. And then I'm going to take that and divide by 12. Remember I asked you to show division using a fraction? I prefer it this way. Okay. Bottom, evaluate the expression, 8k minus k squared, when k equals 6. So let's substitute first. So you got 8. Instead of k, I'm going to write k, 6 minus k to the second power, or 6 to the second power. Notice that the only thing I did was replace my variable for the 6. What do I do here? I can do the exponents first. 6 to the second power is 36. Copy that. Now that I took care of my exponents, my next line I can do the multiplication. 8 times 6 is 48. Then minus 36, and that gives me 12. Okay. Let me lower this a little bit. Here we go. So what number? And we're number 7 already. Okay, so graph the inequality on the number line. So the inequality says 5 is greater than a number m that we don't know. Well, let's graph that. 5 goes in the middle. Let's just do a couple of numbers on each side. 6 and 7. Here would be 4, and here would be 3. Put a little circle on top of the 5. So 5 has to be greater than this m that I don't know of. So is 5 part of the solution? Yes, it is. So what numbers can I replace m to make that true? So let's take a ridiculous number. And I asked you in class to pick a large number. Let's pick 1,000. Is 5 greater or equal to 1,000? No, it's not. Let's pick another number. 500. Is 5 greater or equal to 500? No, it's not. Now, both of these numbers are on what side? Right side or left side? They're both on this side. So, because these two numbers do not make this inequality true, I will point my arrow the other way. Because these are the numbers I want. And if you don't believe me, you can actually try. So pick a number on the left side. Let's pick 0. Is 5 greater or equal to 0? Yes, it is. And where is 0? On this side. What else? What about 5? Is 5 greater or equal to 5? Well, 5 is definitely not greater than 5, but this one gives you a second option, meaning it's equal to 5. So that's why we shade it. Okay? Solve and check. Easy enough. Do one of these, left and right. Because it's subtraction, I want to do the inverse property here, which is inverse operation, I'm sorry. Add 34. And if I add 34 to one side, I'm going to add 34 to the other side. And here I get 9 and 4 is 13, 83. M equals 83. Remember, these two cross it out because they're completely opposites. And my solution is m equals 83. If I want to substitute, I will get that 83 minus 34 equals 49. Let's see if that's true. On the right side, I know it's 49. Let's see if the left side is actually equal to 49 as well. 13 minus 4 is 9. 7 minus 3 is 4. There we go. 49 equals 49. So that's my check. Here, 6p equals 72. There is the 6 is being multiplied to the variable p. So the inverse of multiplication is division. So let me make my line here, left and right. The opposite of multiplication is division. And I'm going to divide both sides by 6. 6 divided by 6 is 1, and I get 1p, or just simply p. On the other side, 72 divided by 6 is 12. If I substitute, I get 6 times 12 equals 72. Let's see if that's true. Well, 6 times 12 is indeed 72, so my left side equals my right. At the bottom, we have little decimals here. So, h plus 2.98. Let's do minus 2.98 because that's the opposite of addition. Minus 298 on this side. So these two cross out, leaving me with h on one side. And then here, 14 minus 8 is 6. 13 minus 9 is 4. And that gives me 0.46. Okay. If I do my check, I will have 3.44 equals h, which I know it's 0.46. Plus 2.98. Okay, so if I add these two, will it give me 3.44? Let's see, 8 plus 6 is 14, carry 1, 10, 14, and guess what? Yes, it does. So my left side equals my right. This one is a fraction, an equation with a fraction. Okay, so this one I want you to use the reciprocal of 1 over 4, and the reciprocal, let me do the left and right. The reciprocal of 1 over 4 is 4 over 1. I'll multiply the other side by 4 over 1 as well. So this 1 and 1, 4, the 1's cross out, the 4 cross out, giving me 1w, or simply w. And on the other side, I have 12 times 4 over 1. I'm going to put 12 as a fraction over 1. On top, 12 times 4 is 48. And the bottom, 1 times 1 is just 1, or w equals 48. Let's check. 1 over 4 times 12, or 48, is 1/4 of 48, 12. Indeed it is. So here it's this. And this one, if I multiply, I get 48 over 4, which is the same thing as 12. Okay. Okay, so let me lower this a little bit. No. Alright, so we did those. Change my pen. 9. Combine the following expressions. Okay, definitely. I guess if you're seeing this, so definitely a hint that this is going to be on this test. So we want to do the distributive property, right here, and the bird attacking the pigs over here too. So 3 times 2c is 6c. 3 times 5 is 15. Plus 3 times 7 is 21k. And minus 3 times 2 is 6. Is there anything that I can combine? Well, the 6c stays here. Nobody else is a c. I'm going to move the 21k right next to it. And I'm going to put the 15 over here, which is a number, and the 6. Please make sure you bring the minus with it. Everything can stay the same. 6c stays the same. 21k stays the same. But I can combine 15 minus 6, which is 9. So final answer is 6c plus 21 plus 9. Factor. Let's see if I gave you a little harder one than yesterday. So plus 32i. So basically this is what I'm looking for something that was like this. Okay, so what did I use? What did I use via distributive property to get 24m, 8c, and 32y? So we're looking for the greatest common factor here. Okay, the greatest number should go outside. 2 goes, 3 goes. We can use 2's. You can do by 2's, or if you notice, 8 also go to all of them. 8 goes into 24 3 times, or 3m. 8 goes into 8c 1 time, or just 1c. And the 8 goes in 32 4 times, or 4y. This number goes out here, and all these 3 numbers go inside. You can always double check. 8 and 3m is 24m. 8 and 1c is 8c, and 8 and 4y equals 32y. Okay. Another combined like terms, so let's see. Birds attacking the pigs here. 4 and 3a is 12a. 4 and 2 is 8. 4 times 2 is 8. Plus 3 times 5a is 15a. Minus, and 3 times 2 is 6. There are things I can combine, so let's move things around. The community property, or the associative property. Now the community property say I can move these around, so 12a, I'll put those together. And then 8 and 6 will be next to each other. Oops, I forgot the plus sign here. Forgot to circle. And then there. So 12a and 15a is 27a, sorry. And 8 minus 6 is just plus 2. So that's my final answer. Okay. So let's go to 12. Try again. The cost of a cup of coffee, I forgot the of, is it's $2.75. Sam spent $22. Write an equation to find the number of number of cups bought. My God, can I read? Then solve the equation. So here we go. You could write an equation 2 ways. I know that 2.75 is a cup of coffee, right? How many did I buy? I don't know. So 2 times 275, which is the cost, multiplied by the number of cups of coffee, which I don't know, and I'll call it C, right? Because those are the cups of coffee. Coffee. 2.75 times the number of cups will give me my total, which is 22. So there is your equation. 2.75 times the number of cups. Well, what kind of equation? This is a multiplication equation. It's 2.75 times C. Well, the opposite is division, so I'm going to divide both sides by 2.75. This crosses out, becomes just simply 1C, or C. On this side, I get $22 divided by 275. How many cups of coffee was he able to spend? I have no idea. Maybe 7, 6. Let's say 6. So let's use our old calculator here. Not my alarm. Calculator. Oh, 22 divided by 2.75, which is 3, about 8. There you go, 8. So the number of cups of coffee that was bought were 8. You can always check. If you go back to your original equation, it would be 2.75 for each cup times, if you buy 8 cups, will you actually spend 22? If you multiply these two, you actually get 22. Well, my equation is correct. Okay, hopefully you remember this. This will be on your test, independent. The table below shows the number of books and the total cost. Write an equation that describes the relationship, and then graph it. Complete the sentence. So, books and total. Complete the sentence, remember? So, does the books depend on the total, or the total that you spend depends on the book? I'm hoping it will say the total cost, or the total you spend, depends on the books. Right? If you pick one book, you only pay a certain amount. The more books you pick, the higher your total. So the total definitely depends on the books. My equation, let's translate. T for total depends on the books. Right? But obviously there's a relationship here. Hopefully you noticed. It'd be what? Times 8. So let's see if this works. If I bought 4 books, 8 times 4 is 32. Check. If I bought 5 books, 8 times 5 is 40. Good. If I bought 8 books, 8 times 8 is 64. So this is my equation. So the total would be, to find the total, I would get 8 and multiply it by the number of books. Let's graph this. Ooh, how am I going to do this? All right, here, extend the line. Extend the line. Okay, so this is my dependent. This is my independent. My dependent, I need to go, oh, well, let's do my, here would be 1. Notice I'm standing this line, and I'm writing my number right under the extension. Please do that, so that you don't write the numbers between boxes. 6, 7, 8, let's just go up to 9. On this side, what should we go by? Oh my god, 32. No, you can't go by 32. Let's go by 8s. 8, 16, 24, 32, 40, 48, I don't know, 56, 64. Graph this. It says here that 4 books, it will cost me 32, so there's my dot. 5 is here, 6 is here, 7 is here, and I could stand the line. Okay, and make sure you put an arrow there as well. So if I bought 1 book, how much would it cost? Right here, $8. If I bought 9 books, let's follow the graph. I would spend this much, which I have no idea what it is. In this case, would be 72. About 7 books, 56. 2 books, 16. So notice that, okay, it falls on my line, okay? But I needed to know this guy. This was important. My equation. The total depends on books. T equals 8b. Okay, so let me lower it. I think we have one more. Same thing. Let's see what this says. Weeks and inches. So something is growing every week. Okay. So complete the sentence. the inches depends on the weeks or the weeks depend on the inches. So I'm going to say the total inches, okay, that this thing is growing, I have no idea what it is, depends on the number of weeks. Okay, so the longer the time, the more the weeks, the taller or bigger you are. So let's change that. Total inches, let's call it, I don't know, let's use T, okay, just to be more original. Depends equals, and then W for weeks. What's the relationship here though? Go side to side. And it looks like it's a times 12 relationship. Okay. 1 week would be 1 times 12, which is 12. Check. Let's see 4 weeks. If it's 4 weeks, 4 times 12 is 48. Check. So all these seem to work. All right, so that's my equation. Let's extend this. This will be my dependent. This will be my independent. So my independent is, my dependence is my total. So here, I'll go 0. Okay, my total, whatever I'm going, so it's going to be my inches. This is going to be the number of weeks. This one is easy. Let's see, can I have 1, 2, 3? I think I can make it every 2. I hate bunching them up. 1, 2, skip 2 boxes, 3, skip 2 boxes, 4, skip 2 boxes, 5. Not bad. How about up and down? We're going to go by 12s. Can we go 12? Let me have 12, 24, 36, 48, 60. We could also skip by 2s. Alright, so every 2 boxes would be 12. Skip 2 again, 24. Skip 2 again, 36. Skip 2 again, 48, excuse me. And skip 2 here, 60. So it would be in 1 week, 12 inches, in 2, 24, in 3, 36, 4, 48, and in 5, 60. And we can go on and on and on. So connect the dot, stretch the thing out. Okay, and here is our graph. Okay, so that wasn't too bad. We are going to review tomorrow in class. Okay, so hopefully we'll be ready for Wednesday's or Thursday's test, depending on the class that you are. And that's it.